So we have books, and under each book we have the location. Maybe we have a last user, because that's all we care about. We're not going to expose any other information than its last user. We might store it in the database. We might even not have this in the database. We might have to mock it out. But this is the user that we're saying we want. We're building our application, and every single time we come up with a new thing that we want to display, we just add it to our schema. It doesn't matter if it's there. It doesn't matter, if it's not implemented yet or what have you. We're just going to say it here, and it's not our job to implement it right now. We have books, we have a location, and we have a last user for each book. Maybe we also have just general information. And maybe that information, that book information, is an object itself, which has other fields on it, like title, first name of author, last name of author, genre. Maybe it has all those different things. We're not going to write it all out right now. But then you have your users. And you have recent books. Maybe you want to know the things that they read, because they're your friends and you want to read books that are like theirs. Maybe you can go find them at one of the locations. And this might be a list of book objects. You can specify what kinds of things that they are. All these also, as I said, this isn't going to be valid, but just as an example, you will also specify what kinds of information is stored there and whether it's required or not using this exclamation point. There are other kinds of things that you can do in your schema, but essentially the schema is your way of saying very upfront what kinds of things are accessible via your API. And then you might have your locations and books, and you might also, maybe you just want the count of that book too, right? And then maybe this location also has hours that it's available. Just information about the location. Now, when you're making a request, instead, you just have one endpoint. Instead of /books and /users and /locations, you just have /GraphQL. And in here, you specify a query that matches your schema. So your query might be something like, let's say that we want the first name of the most recent book for a user with a certain ID. Like, maybe we know that Dongil's ID is 123, and we want to figure out his last book and some information about it. So we say user, maybe we have a variable here that we can query on, ID 123. We know that's Dongil, we got it some other way. And then in here, we got recent books. And then in recent books, maybe we have, each book itself has information about it. So we go to information, then we said information might have an author on it. So you go to author, and you get just the first name. We just want, all we want is the first name of the most recent author of the first name of the author of the most recent book that Dongil read. That's all we want. We just want that one thing. Now, if we were doing this via REST, we'd probably have to go through users / users $Q ID equals 123, and we get Dongil. And we'd look at this giant blob of text that printed out for Dongil. We would see, Dongil's entire life history, where he was born, where he was raised, his high school, how many books he's read over his lifetime, what his favorite genres are, what his favorite authors are. And somewhere mixed in all that would be his most recent books. And we would take the first one, and then we would send a new request to /books. And /books would give us this, and we would send that book. And /books would give us this long list of information about that book, where it was published, who it was published by, what languages you can find it in, how many pages it has, how many characters it has in it, how many words it has in it. And somewhere in there would probably be the name of the author. And now, and probably in there too would be the first name of the author. But we can make this even more complicated. We could go, we could call the user's application, call the user again, because maybe that author was a user and we want to know about his history, and so on and so forth. We can keep making these network calls over and over because we keep getting information that we're not sure what to do with until we have it. Whereas with GraphQL, you make this one nice request saying everything that you want in order, and it will return you just that one thing. Not a big blob of text. It'll just give you the first thing. That's kind of the motivation. You get to eschew some of the problems that REST introduces. God, I just talked through a lot of these slides without presenting them. Anyway, it's all good. So one other thing that I didn't mention about REST is it has the ability to not only get information, but also place information in the database. Being an API layer doesn't care what kind of database you actually have. It doesn't care if you're just caching it on the client, or if you're storing it in SQL, or if you're storing it in Mongo, or if you're actually just sending it to a different API somewhere else that's doing their own storage of it. It's not important to you. All you want to do is send that. That's the beauty of an API, is it abstracts away all of that kind of information from you. You have that same kind of functionality with GraphQL, but hopefully the case for an API in general is clear. Whether you're using REST, whether you're using GraphQL, whether you're using RPC, or just direct, directly calling other APIs that are out there in the world, hopefully the case for having an API is very clear. You don't want to have to bake all of your logic into a monolithic architecture that you need to continue to change and employ as you change and employ your app. So another really big benefit of having an API is exposing it to the outside world. Like we were talking about with your example with the books, you can very easily now be like, okay, I have all this great data. I want to empower other users to go ahead and use it. And I'll probably make money, because that's the ultimate goal probably if you're making a website or web app, is you're probably trying to make money. Also I can gain more recognition for what's going on. So you can go and use the Google Maps API. You don't have to redo all of the work yourself. Let's say that you're trying to put the locations of all the books on a map to display. You don't want to have to reinvent the wheel, re-render a map, paint it pixel by pixel on the screen. You can just call Google Maps. It'll give you, an IMG or a PNG or a JPEG or whatever kind of file type that you want to display that map on your web app just by calling their API. Similarly to how someone else can call your books API and find the locations. Maybe plan out a route for you. So now I'm going to stop talking as much, and we're going to try to do this demo. I've never done this demo before, which is the best way to start any demo. But I'm confident, that it's going to work out once we get the link to actually go through. Oh, I see, you can't click on it. So if you guys want to pull it up yourselves, we can go through it together. If you search Apollo building a GraphQL server, I imagine it'll come up. In fact, let me just do that to verify. Yeah, how to build a GraphQL server. Apollo GraphQL. This seems good. It's going to talk about some useful things, and then I'm just going to have instructions for you. So you guys all need to have npm installed. And I think that's pretty much it. I think if you have npm installed, pretty much good. Everyone have npm installed on their machines? All right, if you don't, and you're in a Mac, just type brew install npm, and then you're done. It's the precursor. All right. This isn't my computer. Can I use your computer to do random things?
Do you want to use your computer? What's the problem?
Oh, yeah, I do need that.
All right.
Thanks, Otto. No worries. Yeah, that's better, because I know that I don't get control. So this demo is going to walk us through actually setting up a GraphQL schema. Rather than just hearing me talk about it or learning what it might be abstractly, we can make it. And it's going to be defined pretty openly with a lot of things already baked in. I haven't actually done this demo, but I did look through it at the very least. And I did help someone else do it once, so that kind of counts. All right, so let's get set up. We want to clone this repo. I did that part. And oh yeah, that's my bad. Thank you. And then we want to cd into the directory, install it, and then just run the script that's already installed, npm start. So now it says Graphql is running localhost 3000 Graphql.
Adam, could you increase the size of the text?
Yes. Good? Cool. So it says that we can do this thing called test string. Alright. And this test string says it works. Alright, I guess we're done. No. So let's try to actually add things to our schema. So let's go to data, Schema Js. So our schema now only says we can have a test string, and that will return a string. That's all it says. Alright? Any recommendations for things we can add? Alright, it's suggesting authors and posts. We don't need to do it that way. We can also just do the books example, right? Since we've already gotten somewhat familiar with that. I say we do that. Going off the rails.
Should make that bigger. Like
Thank you.
font size.
So let's say we have type book. And we're going to want to have that have a few things. It has book information, which will return a book information type. So we'll have to make another type for that. And it'll have a, what do we have over there? Location and a last user. Maybe we should also have like an is available boolean, right? So location is going to be a string. Is available. We'll probably want to let users know, can you rent this from this location or not? Or maybe that's just included in the location. It's okay. We can make it up as we go along. And that's going to be boolean. And last user. It's going to be a user type. So now we have these two types we just introduced, book information, which should be capitalized, and user. Feel free to make your own schema if you want. I don't know if anyone's following along with me. That's okay. So book information is probably going to have an author, a string, and a last user as well, which is also still just going to be a user. Now, we already have that. What else do we want from the book information? Any ideas?
Number of characters.
Oh, we want that one. Number of characters, which is an int. Someone was listening. Now we also need to make the user type, which has first name, last name. Maybe it also has books rented, which is a list of book. And it also says books returned, which is a list of books. So maybe we should name this better. Books currently rented. Why not? Anything else we need to define here? I think we're good. Alright, what does this say next to in the tutorial? Alright, has these things going on. We got a post and a query. We're not doing that. So we're also going to need to have actual data that we access, right? It's not enough to just define a schema. We want to say, when you ask for a book, what kind of stuff are you going to get back? And that's where you implement in your resolvers. Also, I just realized I'm like almost out of time. Do I need to relinquish the microphone at like noon?
You probably can go to like 12:05, 12:10-ish. If
Okay.
you have
So-
like 15 more minutes.
Okay. In that case, I'm not gonna, write code in front of you guys and show you how this works, because because I think that we could spend our time a little better. So I guess before I just say, screw the tutorial, let's move on, is there anything that you guys want to see aside from it work, because that might take like 10 minutes, then I won't answer any questions. Cool. I really recommend you go through this tutorial for building a GraphQL schema, especially if you guys are building out data types that are intertwined, that have a lot going on. It can really help you to just separate out up front what kinds of things you guys want. As an example, I'm working on this finance app. Are you also working on this?
No, I heard of it.
Things are not where I thought they were. Yeah. So this is an example of the schema that we're building. We want to build a finance app that lets you track all of your resources over time, and it's going to call out to a whole bunch of different APIs. Maybe it'll call out to Chase Bank and Bank of America and flight programs to see how many miles you have and things like that. And so we have these different types that are in there. And you see there are a lot of to-dos in there. So one of the great benefits of building in GraphQL is you can specify up front the kinds of things you want. Like, for instance, the recent books or the count of books without having to implement it up front. Or in this case, we have our transaction type input, which we've created, and we say that we definitely want it, this is what it's going to look like. But we can start even building things around it, even though the back-end database might not give that back. So when you're trying to build things up really quickly, this is a really good tool, and you want to build things up in a type-safe way so that you are always accessing the kind of data that you want and just the right amount of data. GraphQL is a really, really good tool, especially if you start building your application around it early. It can simplify your process a lot and make working in a team a lot easier because people can simultaneously be developing all the data on the back end and the interactions therein, while people who are working on the front end developing the kind of information that you're going to display and how you're going to display it without those two needing to be synced up all the time. Cool, that's much spiel. So, with that said, I know that I'm about out of time, but I'd love to open up the floor to questions. These don't need to be questions about GraphQL, about Meteor. It can just be questions about what's it like leaving MIT and finding a job? Or what did you do over IAP, Adam? I worked. Yeah. Except last IAP. That was a good time. Anyway.
What did you do last time?
Last IAP, I went skiing for a month. It was great. Yeah, it was really nice. I pretty much always treated IAP as a vacation. Because you don't get a summer vacation because you're interning. Right. What other questions can I answer? Yeah.
Are API URIs solely for users to work with, or can have a server work with those?
I think that the server often, extremely often does. Especially, let's say that you're building out your own API that someone else might call. That within that might have to get some information from Google Maps, for instance. It might need to get some information about a location that's passed into it. It's not going to rebuild the wheel right there. It's going to just make a call from that server to the Google Maps API, get that information, and bake it into the response that we're giving the user. Yeah, good question. Yeah, go ahead. So you're saying that when you have a certain API endpoint, like a route, there might be methods that you can do within that. For instance, in posts, there might be get post by author as a method or something like that. Yeah, so that is something that you would build out on your own. That's something that would match your your kind of data requirements on the client side. And those are simply passed, I believe, in the actual URI, or the URL of the HTTP request that you're making, or in the query variables. Similar to how we were describing elements of the schema here. So you might have, users, and then instead of recent books, you'd say, get recent books with filter. And you might have a filter of only recent books that were read on Tuesdays, or something like that. You would make that method here, whereas in a REST API, you might make that method only available through that endpoint, and you'd specify it on your server the same way as you would here. Yeah, go ahead.
Is Meteor a framework that helps you build a GraphQL server?
Meteor is a framework that helps you build a full stack application.
Okay.
So we have two frameworks. Well, we have a framework and a set of tools. Meteor is our framework. It's really exceptional as a build tool. I really strongly recommend it. It gives you great features like hot code reload, not push to deploy, but like click a button and you deploy to Galaxy, which is our hosting website, and a lot of other good things that you can read about. This other set of tools that we're working with right now is called Apollo. So Apollo allows you to create GraphQL servers, GraphQL clients, and also see analytics and use a lot of the benefits of GraphQL that we didn't even get to talk about today. So we talked a little bit about why GraphQL is good because it lets you organize your stuff better, but it also has this really great element of having types on it. Like when you ask for the count of a book, or the count of a number of books in a location, you know that it's going to be a number. Whereas when you send that request to the REST API, you have no idea what you're getting back. You might be getting back like really harmful, like to your security scripts that when you try to evaluate are going to infect your program. So now you need to build out like a ton of other things around that kind of threat, as well as do a lot of different parsing to figure out what you're actually getting back from the REST endpoint. So you have this type here, which just by default is nicer. You know exactly what you're getting back. But then on top of that, you can do more useful things with this information that you have, because you know exactly what kind of data is available on the schema. So that's Apollo versus versus Meteor. Yeah. Other questions? Cool. Well, if you have any, let me know, or I can drop my email somewhere.
You can join the whiteboard.
I will. I'm really good at drawing. You can all